Okay, hi everybody. Welcome back. This is still topic 1, Introduction to Human Factors and Ergonomics. Now we're moving on to 1.2, General Guidelines for Design and Practice. 1.1, you should watch that one first if you haven't. That's on the history and definitions of this field. All right, so, and this again comes from the textbook, chapter 1. That's where most of this is coming from. So, some of the goals of human factors in ergonomics, as a pretty consistently we're talking about from that systems perspective, is we want to support the interactions of the humans and other things in the system. So human to human interaction, human technology interaction, human, whatever. And what we ultimately are hoping that, applications of our of these principles and methods will do is you can enhance the performance of the system. This might be, more productivity. We talked about how in the history aspects, even things like looking at the individual movements of an assembly line worker, each individual movement. If we study that at that smallest level, at that most detailed level, and its relationship at the largest level, we can be, looking for ways to reduce error likelihood and improve productivity, make it safer, make it more comfortable, make it faster, all of those. Increasing safety, yes. As I mentioned a few times in the previous lectures here, it's not only that we want our workers to be safe so that they are individually healthy and happy people, but also the productivity and the effectiveness of our system depends on the health and safety of the workers in that system. So yeah, obviously we don't want to, it's a bad thing if anybody is in an accident, is hurt, but it also has an economic cost to our system. So, sometimes as crass as it is, that's what makes the decisions move. Right, less lost time at work. All right, and increasing user satisfaction. So we might have it effective, we might have it healthy, but people just, they don't like it. That's just it's not doing what I want to do. I'm therefore, as a human, not going to really try too hard to try to interface with it. So when you have a good design, a good human-centered interfacing design, then worker productivity is higher, whole system works better. All right. When I say, or when we say supporting humans, recognize that humans interact with systems from different perspectives, different roles, right? So here are just some examples. We can have, operators. We have people who are doing a job, a task, and the technologies around them are aiding them in that task. So probably what these folks are doing here. They might be maintainers. Again, maybe this guy's more of a I don't know. One of these is going to be a maintenance. Here we go. So you got to design a system that not only will work with the people working on it, but when you got to get in and fix things, that's oftentimes a human that has to interface with that too. So, safety valves, maintenance access, those sorts of things. And then, of course, we can have users or consumers, right? So we're designing for humans that have certain abilities, certain limitations, and ultimately they have to be satisfied. They have to ultimately want to use these technologies. So that there's the subjective aspect of it as well. All right. And I've got 5 or 6 categories of what a human factors in ergonomics or human factors engineer might come up with as a solution. Okay, so I'm always saying, we're pushing to solve problems. We can use design to solve problems, but there's a lot of different ways that design could impact a system. So the most obvious here would be, let's say, equipment. Okay, so this person is sitting in an ergonomically designed chair. That's equipment for doing work, right? The angle of her line of sight is pretty close to ideal for the way that humans process visual information, basically at the horizon and slightly below. She's got good posture, because of the equipment that is supporting her there. So this is supporting the human in that work system, making them happier, healthier, safer, more productive. Similarly, let's look at a much more complex environment. This cockpit and the arrangement of displays and controls is an equipment decision, equipment point. Advanced interfaces that we have in our pockets now are smartphones, even mechanical tools. And then, of course, here, this is an example of equipment design that is intended to limit interaction. So sometimes you're promoting interaction, and sometimes you're constraining it, and it's all about what your goals are. In this case, the idea would be for at least for younger children to not have easy access to what could be a dangerous pill. Of course, the downside of this is also then elderly folks with arthritis have problems opening the pills that they need. So, so you've got to consider your audience and design for that. So equipment design, that's one. We could also redesign a task, use the same people, same equipment, just do it a little differently, do it in a different order, rearrange your workspace so it's a little more beneficial for some aspects of a task than from others. You can imagine that the items you need to use, the tools you need to use most frequently should be located in a place where you can most easily reach them and use them. And to some extent, this is workplace or task design. I guess this is kind of blends into this, right? So environmental design, do we improve the lighting in this space, the auditory noise, the air quality, the temperature, we'll talk about the climate altogether. This, in Texas, we have heat and humidity to think about. In other parts of the world, you have cold and frostbite and wind, if it's outdoor, so we have to consider all of those things. Environment can also be extended to some of the social aspects of the workplace, like the culture of safety, the social culture, within a working group. Selection, here you go. Great question for a midterm. Would be if I were to say true or false, get ready, true or false, it is good human factors design practice to only hire people who are strong enough to do this particular job. And it's going to sound, I'm going to word it in a way that's really makes you want to say, that doesn't sound right. We're supposed to be, open to all peoples. And I will say, while that's, what I don't want to say here is I'm only going to hire men, for example. Let's say I'm doing a construction job and I need people to lift heavy things. It would be inappropriate, sexist, and, potentially, borderline illegal if I said only men should apply, and so that's, it's excluding a group because it's assuming that, they're less physically capable, I suppose, which is, not appropriate. But I could say I'm only going to hire people who can demonstrate that they can lift 50 pounds 20 times above their head. And that's a reasonable thing to require. But I don't say only men can do that. I'm going to say, hey, anybody who can demonstrate the ability to do this, is capable to do this job. Similarly, I wouldn't say, hey, I'm going to hire a new engineer, but what we've got here are these other people who, we got to give everybody a fair shot at this. No, I can say I need somebody with this skill set, physical or cognitive, or their area of study. And I can say that is a human factor solution. I need to hire somebody that has this capability. So again, there it is. All right. And last one here is training. So designing of training programs, how do you help a human, learn the specifics of how to do a specific task? There are design aspects of that. In fact, there's an entire, subfield within human factors and ergonomics, which is training factors. And you'll see things like the use of virtual reality or, other types of research into what are effective ways for preparing people to do things in their work environment, in a relatively safe, controlled context. All right. Now, I hear a lot from, I have friends who are, I've been in this field for a couple of decades now, grad school included. And I've got friends who are working as human factors professionals for large companies, for government groups, I've got actually former students who are doing this sort of work to design new technologies, new apps and things. And there is a very common complaint that I hear among my colleagues that, if they're part of a big company, there will commonly be a developed idea and it'll get pushed to a point where it's like, okay, we have a prototype concept. Now let's throw it over the fence to the human factors people and have them tell us, what we did so well with this. And then the human factors people say, well, why did you do it this way instead of that way? Or what did you talk to a user, a human user of this previous system to see what worked and what didn't before you designed this? And there's a lot of examples of not taking the human user into account adequately and just pushing a new technology. And, the example that it's getting kind of dated now, but there was a transition in Windows systems that Texas A&M University went through maybe a little 5 to 8 years ago, something like that. And they did this big transition to Windows 8, I think. And it was this, hey, here's the new technology, let's do it. And across campus transitioned to that, and it did not meet the needs of the instructors or the students. And so that lasted about a year. And then there was, an update or an upgrade that essentially took a lot of the functionality back to the previous version of Windows 7. I think they fixed a lot of it with the current version of Windows. So just to make that clear, but it was an interesting sort of technology driven decision, as opposed to let's look at the humans who are doing the work and the factors that work for them and what doesn't work and what could they have better produced. And if they don't come until after the fact, it can be very costly. So that's the main point I wanted to make on this slide here, is that if we wait until there's a developed idea and then we say, all right, now human factors folks, can you tell us what we might need to tweak here at the end to make it work with humans? And it's commonly assumed that will be an easy process, but generally what happens, and this comes through a number of different studies and economic analyses, it's generally much more expensive to do it in this reactive way. You're risking that you're going to have to do a massive redesign, and it's going to cost a lot of time and effort to fix things, as opposed to if you go on the early end, the proactive approach to human factors and ergonomics in the design cycle is get it on the early end, learn what the human needs, learn what would support the human in this interaction best, and design for that. And then when you get to this prototype stage, it's much less that needs to be changed. So this the human factors people are the ones who say, yeah, but maybe do this or that. And they're not necessarily the ones that have to think about, well, we've got this electrical constraint, or we've got this mechanical aspect that has to be supported. I get that there's multiple considerations in the design stage, but the main point here is to show it is a good idea to involve that human factors, human systems thinking in the early stages of design, and dollars will back that up. So I've got an example here. If the human factors design input is done in the earliest parts of the design, it's a relatively small cost in the overall development. And if it's more reactive, it's considerably more expensive, right? So and oftentimes the reactive would be something like, oh, we pushed this product out and somebody hurt themselves with it in a way we didn't anticipate. And so now we have to pay, now we're liable for those sorts of costs, incidents and accidents, right? I forgot to post them, but they will be up by the time this video is up. So the economics of ergonomics, I have a couple of short articles that discuss this. And so if you ever need to make a case to those who control the bucks, with your company or your job, then you can say, hey, look, this shows it would be less expensive if you involve me at the early stage. Okay. I like, this is something that Dr. Copa would always teach from the Pheasant sort of, there was an earlier textbook. This is a great way to kind of summarize why human factors is not immediately thought of as like, this is a very valuable aspect of development, right? And it kind of boils down to the fact that when you're a human, you think you know humans. And so to some extent, you know, these are all like, you'll hear these things and be ready to refute them. You know, if I'm a designer and I made this thing to work for me and I'm a human, it'll work for everybody. If it's satisfactory for me, satisfactory for everybody. Not generally the case. If it's satisfactory for the average person, it'll be satisfactory for everyone. You'll hear me say this a few times in this course. The average person, the completely average person, doesn't exist. You can find the average point in a particular dimension, but there is no such, the best example is anthropometry. If I've got a 50th percentile length torso, and there's a very little chance I've got 50th percentile any other digit, any other anthropometric measure. So very commonly, so the average person essentially is a myth. I could say, well, human variability is so great, it's so different in between people, that we kind of just have to count on humans adapting anyway. Not true. We can design for variability, for ranges of abilities, and we do that, and we have this in several of our principles here. Human factors is expensive, and since products are purchased based on how good they look and not how well they work, then this is all secondary. We can ignore it. Well, then the first smartphones that go out, cool idea, wow, based on appearance and coolness, we'll get them. But then very quickly, hey, this thing doesn't work, and now that idea is out there, and the next, it's going to be developed. The pressures are going to move towards usable and human-centered, intuitive sorts of design. Human factors is about common sense, right? I'm a human, and so I can follow my intuition here. And what we find is, yeah, individual intuition it's not consistent. It's surprising how different people can be. Let's just put it that way. So as much as myself and all of you have the humanity in common, we have so much different that any of these sorts of attitudes are basically the types of things to look out for. And I hope you'll learn, through this course why they're fallacies. Okay. Oh, good. So I like this example. Works a little better if we're in person, but I hope you'll bear with me here. But let's just talk about one very common interface technology that humans interact with, which is a door. Okay, just a door to get from one area to another. It's a barrier between the two for whatever reason. Okay, so now we have to start thinking about, well, functionally, what do we need for doors? And if I'm a human, what do I need supported in the technology of a door system to help me in my goal of, I guess, safely passing through that doorway? So what sorts of human, considerations do we have? And, take a moment if you want to pause this video and kind of take a crack at it yourself, and then see how much I'm just going to come up with my own brainstormed list here just as examples. But by all means, this is meant to be a thought exercise. So, first thing I might think about are, well, what are the dimensions I need to consider for the humans who are going to use this technology, this doorway, right? If it's this, if we've got an NBA basketball team, maybe our doorway needs to be taller than, the one in my room right here, right? Maybe people are, differently abled, and so their physical footprint is more than just 2 feet, right? And so now width is a concern, right? So width and height, we have to consider who are our population here. We have to consider, well, what's a human often doing when passing through a doorway? They are carrying a load, okay? And if that load is a giant pizza, the doorway has to be able to handle me and my load, right? And the giant pizza, right? So and again, you might say, well, that's ridiculous. I don't need my front door to be large enough to handle that size pizza. I'd say, great, but what do you need? What does pass through that door, or what could pass through that doorway? And therefore, do you have the dimensions needed for it? What about the amount of force that's required? This is something you can design. You can make this door easier or harder to pull open in terms of the amount of force. And there are reasons for that, right? So, to some extent, there's an aesthetic for having a big, solid, heavy door that requires you to lean against it. There's going to be this solemnness to whatever's on the other side of that doorway. You also have to consider the fact that if you're going to exert force to open a door, you have to have reactionary force. So you got to think about stuff like the ground in which people are standing on, so they don't slip and fall. Or in these cases, maybe they're not in a completely reasonable sort of posture for exerting force, the amount of force. Sometimes you want, just like we did with the pill bottle example, sometimes you want to constrain and you want to intentionally make it harder. So this, I used to remember off the top of my head, the torque requirement for opening an airplane door. And of course, there's a standard for this. And it has to do with the fact that, like, they don't want wily children to be able to, what's this? And open the door during a flight. They want well-reasoned adults, and so that it's a simple it's a simplification to say that if you can produce this much force, you can make the informed decision to open the door, basically. So yeah, they want a certain amount of force required before you can access that door. Think about our manual resource availability. So not only am I bringing a big pizza in and I need that sort of dimension handled, I have to consider the fact that it takes an arm and a hand to operate this door. And if my arms and hands are unavailable, because I've got an armful of kittens, then how am I going to manipulate that door handle? And maybe what this means is I need an alternative way to activate, that door handle there. Time requirements, how long will the doors be accessed, be open, be closed? Are there reasons, to have them open longer or shorter? We might also consider things like security. So this is what always gets me when I go in and out of the emerging technologies building where I have my office is, if it's on after hours, which commonly it is, I got to slide my ID, and then I got to get my act together and get all the way over to the door and open it before the lock resets. And so there's a timing issue here that doesn't consider the fact I'm commonly carrying arms full of kittens, and I have to operate my wallet and my ID card and then get to the door. I have troubles with it sometimes. Okay, privacy needs. So one of the features of a doorway is to block visual line of sight for reasons where we want private space for doing some tasks, such as using a restroom. So this is funny to me because this is I think this is in it's in Europe somewhere, I forget. But this is like a mirrored, portable bathroom, but one-way mirrored. So yeah, you can't see in from the outside, and it's I think it'd be pretty unnerving. But if you're inside, you can see out plain as day. So anyway, this is just showing, yes, the privacy needs for certain tasks are real. Access control. We want these people to be able to get in and these people not, for whatever reasons. And so we have to think about, how does the door and the technologies around the door support or inhibit, people from coming in. Visibility. I don't know if this has ever happened to anybody, but I have definitely been on both sides of the opening the door, the heavy solid door of, to or from the restroom, and coming into contact with somebody on the other side who was also reaching for the door. So yeah, if you don't realize a door is there, that's a problem. But also if you can't see on either side of the door, that can also be a problem. So these are examples of doorways that, like in this one in particular, it still protects privacy to some extent, but it lets enough light through that you're not going to do that opening the door into somebody who's on the other side and trying to pass from the other side. Another example here, a lot of times this is what this reminds me immediately of a hospital, because it's this very standard. You want to be able to see a little bit so you know you're not going to run into somebody on the other side of that doorway. Directionality matters. Which way does the door open? Okay. And you can imagine, if you can for a moment, let's look at these two doors. Let's say the safety is outside, okay, and that is beyond this door and beyond this door, and you are on the inside in each case. Now imagine that there's a fire in the building and there's a bunch of panicked people and everybody is headed for that exit. Real nice here, because you just kind of like mush up against the door and somebody can push on this and it opens and everybody's outside. But can you imagine now getting kind of bunched up in front of this door and needing to pull the door open this way when the mass of people are going this way and trying to get to the emergency exit? And if this sounds familiar to you, this is actually, I mean, this is just one example. There've been numerous of them, but this is probably a very famous one, the Coconut Grove fire. And many people died. I want to say hundreds, but I don't remember, but it was an awful circumstance where there was a fire inside the lounge. And among other problems, one was the front exits opened not outward, they opened inward. And so as people are rushing in this smoke-filled place and trying to, you know, get to safety, they're also inhibiting the ability to open those doors to get out. So a lot of people died as a result. In fact, there were some major regulations that kind of stemmed from this that now require emergency exits always need to open outward. And that's a human factors design input, right? All right, sanitation. So increasingly a thing today, right? So, you know, grungy, gross door handle or not, if it's something that I'm expected to use my precious fangies on, you know, I gotta know there's no there's no COVID all over it, whatever. But also I might be in an environment where sanitation, sterility is important to maintain, like in a hospital setting, right? Or you know, COVID testing facility. So what you see here, human factors design here, are ways to interact with a doorway that do not require hands at all. Okay, so I can use my butt to open this one, push to open the doors, or I can just, you know, saloon style, just push the, you know, the patient bed or whatever, you know, right through these doors, and they will just open due to the you know, the colliding and pushing elements. All right, I think that's about it. Yeah, so these are just examples, just, you know, some of them are silly, but things to think about, just to brainstorm list, and just a short list here, but just took, you know, a few minutes to think about all the ways that a human would physically, cognitively interact with this technology of a door, and some of the factors you have to consider, task and environmental factors. One thing we'll talk about, let's see, I think it'll be in around topic, it'll be when we talk about controls. I think that's topic 5, something like that. It's in the first half of the class. We'll talk about this idea of an affordance. And an affordance is basically a dimension of a technology that communicates how a human should interact with it. So this handle right here, I know this is silly, but this handle right here communicates to a human, grab and pull. This guy missed it. But a handle tells a human, here's how you interact with me. And it's not a push, it's a pull. That's what a handle communicates, a handle like that, right? So let me show you, because sometimes these affordances don't line up with the human use. So this is an actual picture of a building next to the Industrial and Operations Engineering building at University of Michigan. So when I was a grad student, we ran a contest called the Bad Designs on Campus. By the way, I like to use that as a bonus thing for this class also. So, you know, that'll come up again, bad designs on campus, bad designs in life. But this is an example of one of the award winners. So these are handles that communicate grab and pull, but they communicate it no matter which side of the door you're on. And I can tell you for certain that those doors all only open one way. So 50%, I don't remember which way they go, but 50% of the time you're going grab and pull and thunk and what? And then you have to push. So that handle does not communicate as clear, doesn't communicate push as clearly as it communicates pull. So this would be an example of an ill-fitting affordance, or basically a design, I don't want to call it a problem, but it is a design mismatch for what humans would normally anticipate for how they interact with it. This is another example also from the same contest. And here we have an example of, okay, now I know I need to push to open this door. That's pretty clear. But which side do I push on? And it takes in a little additional attention to realize, I guess you probably push on this side here. But again, significant percentage of the time when people see this, they're like, oh, push. And they push on the wrong side and it doesn't interact like they would anticipate. So affordances are a major aspect of design that we'll talk about again in the controls lecture. All right, so on that topic of design, and now we're kind of wrapping here on this 1.2, you'll hear me often defending the human when there are problems, when there are incidents or accidents. And I'll give a good example is, there's an aircraft accident and there's a big, announcement the next day that says we found the source, or the next day or weeks later, we found the nature of the problem. It was pilot error, and then the underlying assumption is, oh, well, that pilot is dead now, so there's no more problems. I mean, that sounds crass, it sounds cruel, but it happens all the time, or various versions of that. And so then the human factors engineer needs to be able to say, okay, but what were the design factors? What were the factors in the system around that human that contributed to this? Because another human could be in that context. And yes, it maybe was pilot error to some extent, but what was the system doing around the human that contributed to that error occurrence? And so I'll talk about design-induced error, or basically errors, that at sometimes make it more likely that errors will occur than not. Here's a good, I like this one down here. Good example. Is it okay to not save your game? I guess it's okay. Oh, I didn't save my game. So anyway, these, if you assume that the human operator is acting in good faith and attempting tasks that are attempting things that are well reasoned towards a work goal, if you start there, then you can usually find a lot of ways that the design could be improved to make errors less likely to occur. Okay, so on that, I always try to pick one of these stories for the class because I think it's so anyway. So Stephen Casey here, he's a human factors and an ergonomist practitioner, and he's also an author, and he's written these 2 books. I met him. He said he was going to write 5 books, so I'm still waiting for more of them because these have been now a couple decades. But these are short stories, but true accounts of major accidents, incidents and accidents that involve humans and technology. And he basically breaks down, here's the story. This is something, it's almost always a very bad outcome, death and, misery and all that. But let's look at the factors that contributed to it, the human factors, the other system factors. So that's going to be your assignment for this topic. Now, don't go right to this yet because you haven't gotten all the information yet. But I want you to read A Kid in a Car, which is one of the chapters from The Atomic Chef. By the way, if you like this article, I don't know that you'll like it, but if you like learning about a terrible thing in an interesting way, I have these books. I'd be happy to loan them out to anybody. They're great, like pop science, easy to read, so I'd be happy to loan them. I always do. And then we'll have a 1 to 2 page report where you're going to define the problem in a human system sort of structure. This is a slide from the next lecture. And this is an example that I hope you can use to work through the analysis of this A Kid in a Car story. Okay, so that's coming next, 1.3. Thank you.